All right, welcome. Thanks for joining Chapter 7. In Chapter 7, what we're going to be talking about is systems of equations. Pretty cut and dry. It's stuff that we remember from Honors Algebra 1. We will amp it up a little bit, but not that tough. So today we're going to get into two types, solving by substitution and solving using the graphical method. Solving by substitution is when you're going to be solving for one variable first, then sort of plugging in the result into the other equation. That will allow you to then solve numerically for one of the values. The graphical method is when you're going to graph both equations on the same coordinate plane or coordinate axis and find their point of intersection. So it's important to realize here that the point of intersection represents the solution to a system of equations. So when you're solving, algebraically, substitution method, what you're looking for is actually a coordinate. And it's a coordinate where if I were to graph both of the functions, those two functions would be intersecting. We'll talk about a third method as well and how to decide between them. But most important, just realize they're going to have different uses, or different goals, depending on the problem. Graphical method is only going to be helpful if you have a calculator. And we're going to ask you to show everything algebraically, so know how to do it to verify your work. Substitution method, especially easy if it's easy to solve for one of the variables. So like for instance, in this next problem, it's easy to solve for one of the variables here, either of the y's. So I'm going to solve this second equation. And I'm going to say that this is y equals negative 6x minus 6. So right now I have solved for y. I have y. I don't have it numerically. I have it in terms of x. But what that allows me to do is now take this and replace y in the other equation with that. So I have 4x minus, what I know is that y is equal to negative 6x minus 6. So all I've done is replaced this little piece with negative 6x minus 6, and then equals 1. At this point, it just becomes a regular, baseline algebra question. Distribute this negative, so I get 10x plus 6 equals 1. So 10x equals negative 5. So x equals negative 1/2. Yes, you do have to reduce that. So great, I've got x equals negative 1/2. Numerically, I have this. What I can now do is take that and substitute into this x. So I get y is equal to negative 6 times negative 1/2 minus 6, which gives me a positive 3 minus 6, so negative 3. As a final answer, then, you need to make sure that you write your answer as a coordinate, and it always goes alphabetically. So x comma y. This is your final answer. You do need to make sure that you're writing your final answer as a coordinate, especially on homework. Like, you just want to get in the habit of always recognizing it's a coordinate. Graphically, if I wanted to verify this, looking at these two equations, if I solved this one for y, I would get y is equal to 4x minus 1, and the other one, y is equal to negative 6x minus 6. The reason that you'd need to solve these for y is because you're going to use a graphing calculator in order to graph them. And, if you were to graph these, what you'd see is a decreasing line that's really quick and an increasing line that's not so quick. And I'm going to move that line a little bit because it's not super great. And if I were to calculate the point of intersection right here, that point would be negative 1/2, negative 3. And remember that the graphing calculator has a feature that allows you to find the intersection point. If I remember correctly, it's second trace and then 5 for intersection. All right, so just looking at more examples, there's no real notes to this, just a lot of examples. Really not that many examples. We're on slide 3 of 4. All right, so I'm going to solve this. Let me find my correct pens. I have 4x squared plus y equals 3. And negative x minus y is equal to 11. So you could tell that this problem is a little bit more complicated because of this whole x squared thing. I'm going to solve this equation, and I'm going to solve it for y. So I would get here y is equal to negative x minus 11. And then what I'm going to do is take this negative x minus 11 and substitute that into y over here. So that gives me 4x squared minus x minus 11 equals 3. If I set this equal to 0, then I get 4x squared minus x minus 14 equals 0. And then I can factor this. I need numbers that multiply to 4, which is possibly 1 and 4 or 2 and 2. I happen to know that it's going to be 1 and 4. And both of those are x's. And then I need numbers that multiply to a negative 14. But when they multiply to negative 14, one of those numbers has to get multiplied by this 4, because this whole outside multiplication will happen, so that the sum of those two things and these two things gives me a negative 1. And that's going to be a negative 2 and a positive 7. And let's just go through this. This is type 2 factoring. And if you did it using like split the middle, that's totally fine. I just like to do it using thought process. 4x times x gives me 4x squared. 7 times negative 2 gives me negative 14. And if you were to multiply outside and inside, you'd get a positive 7x and a negative 8x, which combined would give me this negative x. Again, if you want to do the other sort of more structured approach, feel free. Here I get x is equal to negative 4/7. Here I get x is equal to 2. Just kidding, this isn't 4/7, you know. I don't know how to solve a two-step equation. This is negative 7/4. So I hope you didn't write that the way I did. So what is this really telling us? It's not like no solution or infinitely many solutions. You know, think about what this graph looks like. This is a parabola, and this is a line. So, you know, graphically what you've got going on is you have some parabola that looks like something like this, I believe. And then you've got some line looking something like this. So it makes sense that there be two solutions because there are going to be 2 points of intersection. So I know that x equals 2 is one of them. X equals negative 7/4 is another one. To solve then, what I do is I just go and I take these x values and I substitute them both in for x. So doing the 2 first, since I listed that coordinate first, I would get y equals negative 2 minus 11, which gives me negative 13. And for the other one, I'd get y equals negative 7/4 minus 11, which gives me 7/4 minus 44/4. That's just 11 written as a fraction of fourths, which gives me negative 37/4. So yeah, you are going to get some wonderful answers in here. You know, it's just one of the ways in which we try and say, like, we're going to make it a little bit more difficult. You know, do some fraction work, be able to do 2 negatives. But that isn't really that bad. And graphically, again, it would look something like this. You'd have to solve both of those for y. So if I solved both of them for y, I'd get y equals negative 4x squared plus 3, which is why I started that up here at 3, had it opening downward because of the negative. And y is equal to negative x minus 11, which was just that straight line. If you put those into a graphing calculator, you might have to play around with the window. You would, because you can see this negative 13, which isn't on the usual window, but you'd be able to find those 2 coordinates. All right, and then last, you know, amping it up a little bit, look, we have a cubed. So when I look at this question, what I'm thinking right away is I want to solve for y, but I want to solve for it in this equation. Because if I solve for y here, I will have an equation that's in terms of all x's. And that's something that I can do something with, like I could factor something out, or I could do a different type of factoring. So if I solve this for y, I get y equals negative x, which means I'll have x cubed minus 5x minus negative x equals 0. Keep in mind, this is a minus negative. So don't get confused with, you know, those positive negatives. I want to know that you can do these. That gives me x cubed minus 5x plus x, which is minus 4x, equals 0. So I could factor an x out of this. I get x squared minus 4 equals 0. And, you know, whether or not you do it wouldn't make an impact in this problem, but you can do dots, difference of 2 squares factoring. So we'd get x plus 2, x minus 2. And here it's easier to see there are 3 solutions, 0, negative 2, and 2. Now all of those are simply x values. I still need to go and solve for y. So if I'm solving for y, I substitute them into this equation. I'd have y equals negative 0, y equals negative 2, and y equals negative 2. Graphically, if I were to graph this, what I know is I have y equals negative x, which is not entirely that line because I didn't use the straight line tool and I clearly have really bad art skills. So I graphed that line. For this one, I would have something like y equals x cubed plus 5x, which is going to look approximately like that. So again, here you can see there are three solutions: 0, 0, negative 2, 2, and 2, negative 2. All right, that's it in terms of graphically and using the substitution method. What we cover in 7.2, 7.3 is having the elimination method or linear combinations, and bigger systems. These were way too easy. But get started on some of that 7.1 homework. Lots of fun.